Let me ask you something simple. How does Facebook remember all your friends? How does YouTube know which videos you already watched? How does your bank app always show the right balance? How does a game remember your score even after you close it? Every app remembers things, millions of things, and it never forgets. But how? Where does all that information actually go? The answer is one simple thing: a database. Today I'll explain exactly what a database is in the easiest way possible. No confusing tech words, just simple examples anyone can understand. Welcome to SHADHINPATH, where we make tech simple. Let's go. So what is a database? A database is just an organized place to store information so it can be found again quickly. That's it. Storage, but organized. Let me give you two simple pictures. First, think of a library. In a library, books are not thrown on the floor in a big messy pile. They are placed on shelves, sorted by category, with a clear system. So when you want one book out of thousands, you find it in seconds. A database works the same way, but instead of books, it stores data. Second, think of the contacts list on your phone. Every contact has a name, a number, maybe an email. It is neat. It is searchable. You type a name, and instantly you find the person. That is basically a tiny database in your pocket. Now let's see databases in real life. You use them every day without even knowing. When you sign up for a website, your name and email get saved in a database. When you log in, the app checks your password against the database. When you post a photo on Instagram, the photo and caption go into a database. When you add an item to your Amazon cart, that's saved in a database. When you send a message on WhatsApp, it's stored in a database. When you score points in a game, your score is saved in a database. And here's the magic part. When you close the app and come back tomorrow, everything is still there. Your friends, your messages, your photos, your score. Nothing is lost. That is the database, quietly doing its job in the background. John looks surprised and frustrated as his phone apps appear empty. Blank contacts, no photos, no friends. You would have to sign up again every single time. The internet as you know it would simply stop working. So a database is not a small thing. It is the memory of the entire digital world. Okay, so now you know what a database is, but not all databases are the same. There are two main types. Don't worry, this is very simple. The first type is called SQL. SQL is a relational database. The easiest way to picture it: an Excel spreadsheet, rows and columns, neat little boxes, everything lined up. Or think of a school attendance register, every student in a row, every detail in a column, name, roll number, class, all organized. SQL databases store data exactly like that, in neat tables. This is perfect when your data is structured and predictable. For example, a bank, every account has the same fields: name, account number, balance. Same structure for everyone. SQL is ideal. Or an online store. Every order has a product, a price, a date, an address. Neat and predictable. SQL again. Popular SQL databases are MySQL, PostgreSQL, and SQLite. Now the second type is called NoSQL. NoSQL is a non-relational database. The easiest way to picture it: a folder full of different files. One file might be a photo, one might be a long note, one might be a video. They do not all have to look the same. NoSQL is flexible. Each item can be different. This is great when your data is more freeform or changing fast. The most popular one is MongoDB. So here's the simple rule to remember. SQL is like neat tables. Think spreadsheet. NoSQL is like flexible folders. Think mixed files. Both just store and organize data. They only do it in different ways. Now, one more question. Where does a database actually sit inside an app? Let's go back to our restaurant. The front end is the dining area, what the customer sees. The back end is the kitchen, where the work happens. And the database? It's the storage room of the kitchen. It's where all the ingredients and records are kept. The customer never sees the storage room, but the kitchen cannot cook a single dish without it. So the full flow is simple. You tap a button on the front end. The back end receives your request. The back end goes to the database to save or fetch the information. Then it sends the answer back to your screen. And all of that happens in less than a second every single time you use an app. So far, that's the beginner picture. But if you really want to understand databases like a developer, stay with me. Next, I'll show you how they actually work on the inside. tables, keys, relationships, and the tricks that keep them fast and safe. Let's level up. Now let's level up from beginner to a real developer's understanding. Stay with me. This is where it gets powerful. Inside a SQL database, data lives in tables. A table is just like a spreadsheet, rows and columns. Each row is one record. For example, one user. Each column is one piece of info, like name, email, or password. Now the first key idea, the primary key. Every row has a unique ID, so the database can find it exactly. Like a student ID number. No two are the same. Next, relationships. This is why it's called a relational database. Imagine a users table and an orders table. They connect using the user's ID. One user can have many orders. That's called a one-to-many relationship. This linking is what makes databases so powerful. Everything stays connected and organized. Now, how do you actually use the data? With 4 basic actions called CRUD: create, add new data; read, get data out; update, change existing data; delete, remove it. In SQL, you do this by writing simple commands like select to read data or insert to add it. Next, an advanced idea, indexes. This is how databases stay fast. An index is like the index at the back of a book. Instead of reading every page to find a topic, you jump straight to it. Without indexes, a database with millions of rows becomes slow. With them, it stays lightning fast. Now the most important advanced concept, transactions. Imagine sending money. 2 things must happen together. Money leaves one account and arrives in another. A transaction makes sure both happen or neither does. Never just one. This protects your data from getting corrupted. It's why your bank balance is always correct. And finally, scaling. How big apps handle millions of users. 2 tricks, replication, which means keeping copies of the database for speed and safety, and sharding, which means splitting the data across many servers. You don't need this when you start, but this is how giants like Facebook handle billions of records. So let's put it all together. Beginner to advanced. A database stores information in an organized way. It uses tables with keys and relationships to stay connected. It stays fast with indexes, safe with transactions, and massive with replication and sharding. Master this, and you understand the backbone of every app on Earth. If this took you from zero to confident, subscribe to SHADHINPATH for simple, honest tech explained in plain language. Tell me in the comments, which topic should I break down next? Thanks for watching, and I'll see you in the next one.